Entering into college comes with a lot of stress. Most of this can be rooted in time management and having overlapping exams between classes. We have found as college students that there is a disconnect between professors and students when it comes to understanding each other's schedules. Therefore, with our new web app, Exam Scheduler, we have created a way for professors to schedule exams with empathy. Although our target audience is professors, we have created this app with the goal of helping decrease student stress levels and improve their performance in the classroom. What we expect from students is to create an account on our platform and enter in their classes and exam dates on their student dashboard. This is the extent of the student's participation to generate backend data. The main component to our web app is our professor dashboard. Once a professor logs in, he or she can view his or her dashboard and add the classes that they teach this semester. This then pulls data from the backend for every student that is enrolled in the professor's class. After this data is pulled, it is compiled into an interactive dashboard where the professor can click through and view the data in different ways. Now we are going to log in as a student to show you how all of our features work.
Okay, so this is our homepage for Exam Scheduler. We have our motto, stay connected with your students, because the whole point of our web app is for professors to stay connected to their students' schedules. In the top left here, we have our Exam Scheduler logo with a little pencil icon, and we have our sign up and login buttons to the right. So I'm now going to sign up as a student account. I'm going to sign up as Sally. My last name will be Smith, and my email will be sallysmith@live.unc.edu. I will enter in my password and confirm that same password. And then I will specify that I am a student, and I will hit create my account. This then takes me to my student dashboard where I can enter in all of my class names that I'm currently in. So for example, I'm in Comp 426, Section 1 right now, and that adds to my class list, as well as Math 383, Section 4, and that will add too. So now I can enter in my exam dates. So for example, if I have an exam on September 20th, 2020, I can add that to my exam date list. And if I have another exam on October 13th, 2020, it will add that date. So this is the extent to what a student contributes to our website. So now I can log out and go back to our homepage. And for the sake of our presentation, we will log in as an already made professor account. So here I would enter in my username and my password and hit login. And it brings us to the professor dashboard. So here we have a table of all of the exam dates for the students in the professor's classes and the number of students that have an exam on those dates. We can organize this table by the date of the exam and the number of students that have an exam on those days by clicking the headers respectively. And we can also search for how many students have an exam on a particular date by using this search bar right here. So for example, on April 7th, 2020, we have 19 students that have an exam on that day. If we click this button right here, it will refresh the table and we can try a new date. So on May 13th, 2020, no students have an exam. We can also use this field right here for professors to add new classes, and we will give them suggestions on what comp classes they might be interested in adding. And on the bottom here, we have the busiest days for the students. So for example, August 8th, 2020 is the busiest day with 250 students that have an exam. And then here on the right is the scheduled exam dates for the logged in professor. So after the professor looks at all the stuff on his dashboard, he can then sign out using this button, which will bring him to the home screen.
Okay, so here is the backend for our exam scheduler app. So here we have two kinds of objects, or two main kinds of objects that make this work. So we have professor objects and student objects. Um, Professor objects contain the ID, a unique ID for the professor, a first name, last name, email, username, password, and then they contain an array of class objects. So these class objects have an ID and a name, and they have an array of exam date objects. And these exam date objects have day, month, year, and then the total number of students who have an exam on that date. So the way that this object works is, let's say you're this professor, so Caitlin. So one class that you teach is Comp 110.001. And for Comp 110.001, based on this object, you know that on 9/24/2020, you have one student in your class who has an exam. On 11/26/2020, you have three students who have three students in this class who have an exam. And that's how this whole object works. Now this gets populated by the student object, which looks like this. So each student has also ID, first name, last name, email, username, password. And then they have an array of class IDs. So these are all of the IDs of the classes where their information needs to be sent. And then they have an array of date objects. So these are the dates when they have an exam. And these dates need to be sent and tallied up, sent to and tallied up in these classes right here that have these IDs. And then we also have user objects just to make it easier to validate different users' credentials when they sign in. So this has professors and students. So we also have JS files for each of these classes so we can work with them. So this is the professor.js file. So again, it has all the attributes that we were showing you in the JSON file. To construct a professor object that has update and delete methods. It has a get all IDs method, which returns all the IDs for all the professors. It has get all IDs for user, which returns all of the IDs for a particular user. So this should return an array of one ID, so array of length 1. We have find by ID, which returns a professor object of a given ID. Again, this is like a unique ID. We have professor.next, which helps us generate unique IDs for professors. And then we have professor.create, which creates a new professor object. And then we have professor.create class when a professor creates a new class. And then we have professor.get class names, which takes in an array of class IDs and goes through this whole professor.json file and returns a list of all of the class objects that exist within all those professor objects that have these IDs. So it returns all of the classes that have these IDs that are passed in this array. And then we have our class object, which again here we're just using the constructor and to be able to work with these class objects since they're stored within the professor.json file. And then we have our student.js file. So this is the same story. We have a constructor that has all of the arguments that you saw in the student.json. And when we create a new student, we set their classes and dates equal to an empty array. This also has update delete methods. This get all IDs works the same as professor. Same thing for get all IDs for user, find by ID, next ID, and create. Those all work the same as the professor functions. And then here's our index.js file. So this is our RESTful interface that has all our endpoints and is running the show. So this uses Express. We have all of the stuff for cores that we need to make sure that our cookies get saved properly. So this is our front end, and we have credentials true, and we have all this stuff set to make sure our cookie works. We import in professor, class, student objects here. So now I'm just going to go through all of our endpoints and how they work at kind of a high level. So this is login. It just validates the credentials that were entered by the user, and if they work, then it returns a true if the user is a professor, it returns a false if the user is a student, and that way the front end knows where to redirect. We have sign up, which does the same thing. It creates a new user, and it either creates a student or a professor. And then we have logout, which deletes the session.user, and it returns this message, so successfully logged out. So it logs out the user from the session. Now this is our RESTful interface for professors, so we have this /professor endpoint. So this will give you an array of all the IDs for the logged in professor. So again, this gives you an array of length 1, and that the one element in there is the ID of the professor who signed in. You can then use that to use this endpoint. So get /professor/ID, and this one is going to return the actual professor object for that ID. Then we have a put method for put/professor/ID. This one updates the professor object of this ID with just all the new information that comes in the request body. And then we have put method for professor/exam/IDs. This was if they wanted to update the exam dates. And then we have put/professor/create class. So this is an endpoint for when a professor creates a new class, and the same kind of thing where it just ensures that they're the professor who signed in and then creates a new class. And then we have a put method for when a professor deletes a class. So this goes in and removes that class object from their array of classes. And then we have one for when a professor just wants to delete their account. So delete /professor/ID. And again, this goes in, validates it's the professor who signed in who's trying to do this, and then it'll delete their account. And then we have a similar RESTful interface for students. So /student returns the ID of an array of length 1 that contains the ID for the existing student or the student who signed in. So get student/class name/IDs. So this, what this does is it takes an ID for a student, and then it uses the information stored within the student object to go out and get a list of the student's classes, and it returns those. And then, so get /student/ID, so this returns the student object that has this ID. Post/student, so this will create a new student. Okay, so then put /student/ID. So this will update a student's data based on their ID. And then delete /student/ID. So this deletes a student account based on that ID. Okay, then this method, so push /student/ID/create. This method is for when a student adds in a new date. So you pass the ID of the actual student here, and in the request body, you pass in an array of class IDs and an array of dates. And then you go out, you find the student, and then what you have to do is you have to go through all the professor objects, find the classes where that student is enrolled by their ID, and then you have to take the dates that were passed in for those classes, or the classes the students enrolled in, and you have to add to the total stored within the date object for the date that that student passed in, and if that date doesn't exist for that class yet, then you have to create that date. So this basically goes through the whole professor object and increases this tally of how many students have an exam on that date according to the date that the student entered. And then we have another put method, student slash delete slash ID. So for this student, again, this is for when they remove a date. This function handles that, so it does the opposite of the last one. And it goes through the professor object and figures out where to subtract 1 from the tally. And that, and then finally down here, this is just for ensuring that our app is running, and that is our entire backend.
So here is the JavaScript file that manages the login and sign up pages. All of our requests work really well here, and we even have like front end verification for the password and everything. Here is our file for managed classes, which also everything works here with our rendering the page dynamically and accessing the students' data from the backend. Our professor view is where we ran into some difficulties, and that's like, this is definitely the result of the challenges that we faced. The requests for the professor don't work. We hard-coded, for the sake of the presentation, a professor object here so that it would render. Although all of our rendering dynamically changes the site and would appropriately render the page if given a professor object from the backend. That's what's unsuccessful right now. And initially, so some of the challenges, one of the biggest challenges we faced was our goal for this view was, instead of a table, which we ended up having, was we were going to incorporate a calendar library where professors could view the students' busiest days by looking at a heat map calendar. We ended up having to drop our calendar at the last minute and pivot to a self-created table because our data was incompatible with the library. And we even attempted to reformat the structure of our data on the back end, but it was still not being recognized by the library. And after talking about it with Chris, we came to a conclusion that it would not make sense for our website to have an API because all of the data is generated by our own users. We also had an issue of storing the front and back end on the same Git repository and trying to deploy both of them in from the same repo in Heroku, which was really time consuming and wasted really valuable time that we could have definitely used to finish debug and wrap up these professor endpoints from the back end. And to solve this, we had to start completely from scratch and recreate our front and back ends on different Git repos. And then eventually we solved our deployment issues by deploying our front end repo to Netlify and our back end repo to Heroku. And then I think another challenge that we faced was different coding styles among our team members. Like some of us would code in HTML, and then some of us would use jQuery. So, but I do think that we pivoted after realizing that this was causing us a lot of problems really well, and we had really good communication to solve that problem.